Electromagnetic radiation is used for communications, as we've now seen, and also for the transmission of information. The waves that are used in this way are radio waves, microwaves, infrared radiation, and of course light. Now, the idea of using a signal lamp to communicate was first used in the 19th century. This method of long-distance communication needed a code. One code to use was Morse code, a series of long and short flashes of light representing different letters of the alphabet. These signals can only be seen when visibility is good and over short distances. Now, we seem at present to live in an analog world. These things can be louder or quieter, hotter or colder, longer or shorter, on a sliding scale. If we record a sound on a tape recorder, we're putting an analog signal onto tape. Digital signals aren't actually on a sliding scale. They're either on or off. We call this 1 or 0. This is the binary system. There's no in between. So although we use codes to send signals using EM radiation, there are these two types of signal, analog and digital. An analog signal changes in frequency and amplitude all the time in a way that matches the change in the voice or music that's being transmitted. Okay? And that's the analog signal there. Whereas a digital signal only has two values, which we can represent as 0 or 1 or on and off. We see here with the voltage, either it's got a voltage or it has no voltage. Those are your two options. An analog signal varies in frequency and amplitude. A digital signal has two values, either on or off. Now you can convert a signal, which is analog, say voice, music or data, to a code using only values of 0 and 1. The signal then becomes a stream of 0s and 1 values, and these pulses are added to EM waves and transmitted. The signal is received and then decoded to recover the original signal. Both analog and digital signals can pick up unwanted signals that distort the original signal. This is known as noise. Digital signals can be cleaned up by a process known as regeneration because the pulse can be either 0 or 1. So all other intermediate values can be removed. Analog signals can be amplified, but the noise is amplified too. This is the reason why digital signals have a better quality reception. Digital signals give a better quality reception because noise on digital signals is more easily removed. And hopefully this short video will explain that.
Analog and digital signals. There are two different ways of sending information, either by analog or by digital signals. So what's the difference? Well, let's look at the analog signal on screen. We can see that it varies continuously in both amplitude and frequency, and the signal can take one of many different values. Now let's look at a digital signal. So here we see that the signal can only take two values, either a 1 or a 0, which we sometimes call on or off. Digital signals are sent as a series of pulses of either 1s or 0s. Okay, so that's great, but which is better? Well, digital is a much better way of sending information over long distances. Now let's see why. So, here is someone talking on a phone. The signal from their voice is analog, sound, and it enters the phone and is converted to a digital signal, and then sent out via microwaves to a phone mast, which then sends it on to a satellite, and then back down to another phone mast, and then on to the person receiving the phone call. Let's look at the signal received by that phone. If we look, we can see it has picked up a lot of noise or interference, but it's still really obvious exactly what it should look like, so the phone can easily convert it back perfectly to be the same as the original signal. Now let's look at this using analog. So now the analog signal, the sound, enters the phone and is turned into an analog electrical signal and sent down copper wires. Now, note how it picks up noise and interference, and the amplitude is reduced as it travels until it gets to the other phone. Now let's look at it again. It looks very, very different to the original signal now. it's almost completely impossible to know what this signal should have looked like. And it needs amplifying as well. This amplification is only going to amplify the noise just as much as it does the signal. So noise or interference has really damaged the analog signal. And this is why digital is so much better than analog. Noise or interference is just not a problem for digital, but is a huge one for analog, making digital signals much higher quality. Other benefits of digital are that it can carry much more information. In fact, you can send multiple different signals all at the same time, and digital signals are also easily interpreted by computers. Analog and digital signals. There are two different ways
So in terms of analogues and digital signals, which of these are analog and which of these are digital? Okay, so pause your video now and see if you can work out which is which. Okay, so is the volume control on a radio analog or digital? Okay, so you should have seen that it is analog. Traffic lights, are they digital or analog? Okay, they should be digital. Okay, there's only three options. Motorbike throttle, is that going to be analog or digital? You should have said analog. A dimmer switch will also be analog. A light switch will be digital, can only be on or off. A water tap should be analog. Music on a CD should be digital. And music on a tape should be analog. So hopefully you got 100% in that. So moving along, as you saw in the video, you can convert analog into digital signals Okay, so an example could be a security floodlight switches on when you approach. It has an analog input, how much infrared you see, it sees from you, and produces a digital output. Either the light goes on or the light goes off. You could call this, in fact, an analog to digital converter if you wanted to. The problem with analog signals is the noise. Okay, it's the hiss on the sound and the speckly dots on a. When we set a signal over long distances, like in phone lines, the signal gets very weak, so we need to increase the signal, increase the amplitude, boost it. The problem is we're also then boosting up the noise as well. So if we convert the signal into a digital form, then send it, it gets weaker and the noise still creeps in. But the advantage, because it is digital, the receiver can work out what the signal is supposed to look like behind all that noise and reconstruct a clean signal, because it's only going to be on or off, 0 or 1. There's no intermediate noise. So we don't end up boosting the noise along the signal. This is why you get such good pictures on your digital satellite TV. For example, if you have a bad photocopy of a piece of text and you continue photocopying that, you'll get a continually worse photo. But if you read the text yourself, the software in your brain can reconstruct the text because it knows what the letters are supposed to look like, even though they're blurred. So in summary, analog signals suffer from noise but don't need such complex equipment. Digital signals need fast, clever electronics, but we can get rid of the noise because it's obviously easier to work out what the signal was, because there's no intermediate on or off, or 0, 1, between 0 and 1, so we can use computers to work out to remove that noise. And finally, we can also use compression techniques to squeeze a lot of information into a digital signal, which you can't do with analog. And fiber optic cables, which we looked at with total internal reflection, have a huge bandwidth because light is such a high frequency wave.